So yes, our next speaker would have been Stephen Cantrell, who cannot be here today. So he will be replaced by his colleague, Austin Messon.
Yes.
From GTRI, and he will first present the airborne and small form factor 5G NR G0B demo.
Thank you.
You can just with the keys.
Select them, right? Okay. All right, thanks, Robert. Like he said, my name is Austin O'Connell. I'm speaking on behalf of Stephen, who was not able to be here for family matters. I'm actually speaking on the next demo right after this too, so you guys get double the time with me today. So this demo here is on airborne and a small factor G0B. So I would like to share with you guys our motivation for doing this research. We're leveraging OAI in our research in what's known as a mobility inverted network. So for those who aren't familiar with that term, let this picture kind of depict what we're talking about here. So in a traditional cellular network, you have your G0B or your base station at a fixed location at a cell tower site. In a mobility inverted network, your G0B is now, or at least your radio unit is now not in a fixed position, but rather, for example, on a UAV or a drone up in the air. It's able to rapidly move, perhaps even faster than the UEs, the end users within your cellular network. This allows you to maintain optimal channel conditions for all your UEs, despite whatever environment you may be within. One of our other motivations is for the integrated access and backhaul, or IAB, which is part of the specifications for 5G. Also shown in this picture is essentially a daisy chain of G0Bs connecting back to a single 5G core on the ground. This integrated access and backhaul provides an over-the-air wireless link so that you can essentially extend the range of your cellular network. So with all that being said, we need a software-defined radio that is small enough to fit on a UAV or a drone. So considering a low swap radio, a low size, weight, and power option, we went with the Epic Solutions Sidekick NV100 software-defined radio. So just a little bit about the radio here. 40 megahertz channel bandwidth is supported, up to 6 gigahertz, perfect for the FR1 frequency range. Has its own GPS disciplined oscillator. The most notable part on this slide here is its form factor. It's an M.2 form factor, 22 by 80 millimeters, for those who aren't familiar with that. Weighs only 9 grams, consumes about 5 watts of power on average, which is perfect for a battery that you might be able to support on a UAV or drone as well. Comparing it to some stats of some commonly used radios in the OAI community, I know the USERP B210 is a very commonly used one. I also included on these slides the B205 Mini, which is a smaller form factor I know that NI-EDIS has produced. But the NV100 is comparable to these two. 40 megahertz of instantaneous channel bandwidth, comparable to the B210, although I know the B210 has the 3/4 sampling rate working with the 5G standalone mode. The NV100 is able to handle the full 61.44 megasamples per second. Also notable on this slide is the increased A/D and D/A precision. You have 16 bits of full data precision as opposed to the 12 bits. This allows you to have a higher dynamic range for when you're wanting to leverage slightly higher RF signals with more granularity. What we'll be showing at our demo out in the booths, here's a picture of our actual computer. You can see the radio in action. We'll be using the NV100 radio as a G0B, connecting to a coaxial cellular modem, showing off the registration process and seeing it as stable as you'd like to see it. Here's some computer specs as well, but I'm happy to answer any more questions you guys have at the booth. So thanks.
Thank you, Austin. And then we quickly go to the next presentation, which will be wideband high performance, high power 5G NR G0B demo with Epic Sidekick X4 radio.
Thank you. All right, it's me again. I'm showing off, this is actually a fairly similar demo, another Epic Solutions Sidekick radio that we've integrated with OAI, this one being the X4 radio. So for those who aren't familiar with the X4 radio, it's self-labeled as a high power, high performance, high pin count transceiver. In this bottom left picture here is the the blue chip that is surrounded by this red board being a commercial off-the-shelf board with a PCIe interface that allows the X4 to connect to your computer through a PCIe port. Getting right into the specs here for the X4 radio, why you should even consider using the X4 radio for your purposes. Here's maybe a little bit more stronger radios that you might be more familiar with. I know many of you guys are using the B210, so I added that up here as well. The N310, I know those are for people that are looking to achieve higher throughputs and more performance. And finally, the X410 as well, which I know that's the newer radio. I haven't heard much talk about that in the community, but I'm sure that's coming. Notable specs here, the X4 is comparable to the X410 with its 400 megahertz of instantaneous channel bandwidth, which for those who aren't familiar is the maximum channel bandwidth in the FR2 frequency range. And also, again, you'll see with the MV100 demo that I just showed, its A to D and D to A precision is also a higher bit precision than a lot of the USRP radios. It matches the N310 as well. And frequency range is also comparable up to 6 gigahertz, but with some up converters and down converters, we'll be able to match that going forward towards more research in the FR2 frequency range. So just a little bit about, I know you guys are very familiar with the USRP radios. For those who aren't familiar with the Epic Solutions radios, for the record, I don't speak on behalf of Epic Solutions. They're not giving me any commission off this talk. We've used their radios in our labs for a time now, and we have nothing but good things to say about them. But if you're looking to maybe take your research out of the lab environment and maybe into more of a field testable scenario, that's a great reason to use these Epic Solution radios. They have a multitude of form factors, like you'll see in our demos, that make it more desirable for maybe a field testable scenario to meet your needs. And on top of that, they become just more field testable out of the box, and their support forums they're very happy to help you guys out with that. And in general, just more hardware choices for this open source community is always great. We're looking to get access to everyone, these changes that we've made as soon as possible to the public. So again, demo setup for what you'll see out in the booths, very similar to my MV100 demo will be the X4 demo. We'll be having the X4 radio running as a Geno B with 100 megahertz channel bandwidth. We'll be registering a phone and showing off a stable connection of that phone as well. And that's all I have. Thank you, everyone.